Hey everyone, and welcome. Today, we are diving deep into a really different way of thinking about decentralized finance. We're talking about an approach that was built from the ground up to solve the huge problems that are holding DeFi back. We're going to look at Radix and its pretty unique consensus engine, Cerberus, to figure out if they've really cracked the code for the future of finance.
So to really get a sense of what's at stake here, you have to start with this number, $400 trillion. That's roughly the size of the entire global financial system today. It's just a colossal market, and it's all run by a handful of closed institutions. So the opportunity to build something more open, something more efficient, it's almost unimaginably huge.
And yet, here's DeFi's current slice of that pie. It's less than 1/20th of 1%. I mean, after all the hype, all the excitement, that's a surprisingly tiny footprint, right? The first wave of DeFi proved the concept could work, for sure, but it's pretty clear that something is seriously holding it back from hitting that next level.
So that really brings us to the core question here. What is the bottleneck? Why haven't we seen this massive wave of developers just come in and rebuild finance on the blockchain? It's not because they lack ideas, and it's definitely not a lack of ambition. The problem, as we're about to see, is baked right into the tools they've been given to build with.
Yeah, the issue really boils down to the tools that developers are stuck with today. It's a fundamental problem with how dApps, decentralized applications, are actually built and secured, and it's created this massive billion-dollar bottleneck for the entire industry. Just listen to this quote. This comes right from the Radix team, and it is so telling. The problem isn't a lack of creativity. It's that the current platforms, like Ethereum, force developers to spend almost all of their time, 90%, just trying to stop things from blowing up. The whole environment is like a minefield, and it leads to these constant multi-million-dollar hacks and exploits we're always hearing about. And just look at this. This is what it takes to do something that should be super simple, like swapping one token for another on a DEX. It's this incredibly complex dance of sending messages back and forth between all these separate smart contracts. First, you have to give permission, then the DEX calls the token contract, then it calls another token contract. I mean, every single one of these steps is a place where something can go wrong or be exploited. It's literally a house of cards, and the developer has to build it perfectly every single time.
Okay, so how do you possibly fix that? Well, the Radix approach was to go all the way back to the drawing board. They decided to completely rethink what a smart contract should even be. The goal was to build a foundation for developers that's just way more intuitive and, most importantly, secure.
The absolute heart of their solution is this new idea called asset-oriented programming. Now, think about this. Instead of your token just being a number in some contract spreadsheet, the Radix engine treats it like a real, physical object that you can actually hold and move around. And this isn't just some fancy new name. It completely changes how you build an application.
This slide just lays out the difference perfectly. On the left, with the current model, you're just sending messages back and forth, hoping some balance sheet somewhere updates correctly. But on the right, with Radix, your assets are like physical things held in these secure containers called vaults. Moving them is a direct action, not a polite request. And that simple change makes whole categories of bugs and exploits like double spending literally impossible by design.
And this just brilliantly shows you the payoff. Remember that crazy 6-step mess for a simple swap on Ethereum? Well, here's what it looks like on Radix. It's 2 steps. The user puts their tokens into a little temporary container they call a bucket and sends it straight to the DEX. The DEX, which is called a component here, does its thing and just sends a bucket of the new tokens right back. That's it. It's simple, it's intuitive, and it's just fundamentally safer because the platform itself is making sure the assets behave like real things.
So this asset-oriented approach is a total game changer for developers. But you still need an engine that can actually run it all at a global scale without hitting a wall. And that engine is a completely new consensus protocol called Cerberus. Most blockchains work on what's called global ordering. Imagine a single-lane highway. Every single car, every transaction has to get in one single line, one after another. It's a massive bottleneck. Cerberus basically throws that idea out the window. It uses what's called partial ordering. It just recognizes that, hey, a token swap between Alice and Bob has absolutely nothing to do with Carol opening a savings account. Only transactions that actually touch the same stuff need to be ordered together. Everything else can just happen at the same time, in parallel.
The way Radix pulls this off is by pre-sharding its entire ledger into a massive number of little pieces. You can think of each shard as its own independent highway, its own timeline. And on each one of those shards, a really fast and efficient consensus process called local Cerberus keeps everything in order. These shards are the basic building blocks for doing things in parallel on a massive scale.
But here is the real breakthrough. What happens when a transaction needs to touch multiple shards at the same time, like our token swap does? Well, this is where Cerberus dynamically braids the timelines of only the shards it needs and only for that one transaction. This emergent Cerberus process makes sure the swap is atomic, meaning it all happens or none of it does, without ever slowing down the rest of the network. It's pretty incredible.
Now, this whole braiding idea, it's more than just a clever trick. It's really the key to unlocking massive, massive scale, while still keeping the thing that makes DeFi so magical: atomic composability. And that's just a fancy term for different apps being able to work together perfectly in a single all-or-nothing transaction.
You can actually see how the old concepts from traditional systems map directly to these new ones in Cerberus. So a traditional protocol has one leader making one proposal. In Cerberus, for a cross-shard transaction, you get a leader set. That's one leader from each shard involved. They make a merged proposal together. It's the same core ideas, just applied across multiple timelines at once, creating what they call a three-braid instead of a three-chain.
What this means is that a single transaction can just dynamically pull together only the shards it needs. So for our swap, it might grab the shard for the DEX, one for each of the tokens, and one for the user's account. Cerberus braids just those 4 timelines together for a split second, while thousands, maybe millions, of other transactions are happening on other shards completely undisturbed.
So the crucial point is this. Cerberus gives you massive parallel performance, but you don't have to give up atomic composability to get it. It basically solves that huge dilemma that has plagued so many other scaling solutions. You get what feels like unlimited throughput while still letting developers build those complex, cool apps that all work together flawlessly.
All right, so a better programming model and a network that can scale to the moon, that's already huge. But Radix adds one final layer. And this layer is designed to create a really powerful, self-sustaining incentive for the people who are actually going to build this new financial world, the developers.
First up, they created something called the Blueprint Catalog. When a developer deploys code on Radix, it doesn't just become a one-off smart contract. It becomes a blueprint in this on-network catalog. The best way to think of it is like a giant shared library of DeFi Lego bricks. Other developers can then just grab these proven, secure blueprints and use them to build their own stuff, which just massively speeds up development.
And this leads to what might be the most revolutionary part of all, the on-network developer royalty system. The person who creates a blueprint can set a small royalty fee. And then, and this is the amazing part, every single time a transaction on the network uses their code, the network itself automatically pays them that royalty. This creates a direct, decentralized marketplace for good code, rewarding developers for building things that are useful and reusable.
Which brings us right back to our opening question. Radix is making a huge bet here. They're betting that a full-stack solution is the only answer. An asset-oriented language to make building safe, a consensus protocol for unlimited scale, and a royalty system to create a thriving developer economy. The ultimate question is whether this all-in-one approach is finally the key that unlocks DeFi and takes it from this tiny niche market to the foundation of our next global financial system. Thanks for joining us on The Explainer.